Here the last few problems on the Maxima and Minima. Too many problems are solved, still too many are there in the textbook. But first a few, what I mentioned important, no, those are all actually examination point of view important. And these are all actually difficult to rule out, will be not be asked, a remote chance, okay, for the examination. Show that the semi-vertical angle of a cone of maximum, show that the semi-vertical angle of the cone of maximum volume, the volume of the cone is maximum given, of given slant height, volume is maximum is mentioned and slant height of the cone is given means constant, the word given means constant, is tan inverse root 2. It means we have to show that the semi-vertical angle of the cone is tan inverse root 2 under the given conditions. What are those two given conditions? One is volume is maximum, means dV is 0, volume is V, no, dV is 0, dV by dx or dy, with respect to which variable you are differentiating later on depending upon that one. The first order derivative is 0 and slant height L is constant, L is to be taken constant, okay. Now here is the figure. So let x is the radius of the cone, y is the height of the cone. This is the semi-vertical angle actually. This angle between what? The slant height L is the slant height, y is the vertical height, L is the slant height. The angle between y and L is the semi-vertical angle. Theta, we have to do that theta equals to tan inverse 2. So tan inverse root 2. Under the given two conditions, one is volume is maximum, second one is L is constant. Okay. So therefore volume is maximum is given. Therefore you have to get the volume equation. You have to write down the volume equation. And volume equation should have only one variable. Then differentiate with respect to that variable. You will get dV by dy. Equate dV by dy to 0. You will get the required expression theta is tan inverse root 2. Okay. Let x and y are the radius and height of the cone. X is the radius, y the height of the cone. Both are variable. Here L is constant. So this is the slant height. So you can vary the slant height like this. As slant height is varied, then automatically x and y changes. Okay. As slant height is varied, look here. For this slant height, this is y and this is x. If it is inclined further, then actually y decreases, x stretches, x increases. So like that's why x and y are variable. Okay. This is the fixed slant height. This height is what it is changes, automatically x and y also changes. This height changes, then automatically x and y changes. This y and this is x changes. Is it not? But this height remains constant. L remains constant. Slant height. L is the slant height. Given L implies L is constant. Both are variable, x and y are variable. Given L implies L is constant. Whatever the things are written in the for your understanding sake, not for examination. Okay. Given L means in the problem, the statement is there given L. Given means it is constant. Okay. Here x and y are variables and L is constant. Coming to the volume equation, because mentioned that volume is maximum. Which quantity is maximum or minimum is mentioned, then that equation is to be taken. So volume equation for cone is 1 by pi r square. R means radius. Here x is taken just to synchronize with the standard variable x and y. X and y are the standard variables now. That's why to match with that one, I have taken radius as x, height as instead of h, y. Then R and h itಕೊಂಡು proceed ಮಾಡ್ಕೊಂಡು ಹೋಗಬಹುದು. R and h are variable ಅಂತ ತಲೆ ಇಟ್ಟುಕೊಳ್ಳಿಕ್ಕಷ್ಟೇ. Better to convert it to x and y. R is x, h is y. Now two variables x and y, convert it to single variable. Here is the right angle triangle. Okay. Here is the right angle triangle. So OAB is the right angle triangle. And the right angle triangle OAB. So here is 90 degree. Means L is the hypotenuse. Therefore L square is equals to x square plus y square. L is the hypotenuse from the triangle OAB. From the triangle OAB. Okay, x square plus y square is L square, therefore x square. So here x square is done, therefore x square is converted to, easily I can replace for x square as a whole. Therefore I have taken x square is equal to L square minus y square. X square is L square minus y square into y as it is, 1 by 3 pi as it is. Y is multiplied L square y minus y cube. Now differentiating with respect to the single variable left in the RHS, what variable is left out? Y. Therefore differentiating with respect to y. dv by dy, 1 by 3 pi constant outside. So plus or minus is there, you have to differentiate each and every terms. In that one L square is constant, d by dy of y minus d by dy of y cube. Whenever plus or minus is there, you have to differentiate each and every term by keeping constant outside. Okay, 1 by 3 pi, y with respect to y differentiation is 1. Y cube differentiation is 3 into y raised to 3 minus 1, 3y square. Volume is maximum. Therefore, given that volume is maximum, therefore take dv by dy is 0. dv by dy is 0 is taken, is 1 by 3 pi. L square minus 3y square is equal to 0. Implies L square minus 1 by 3 pi constant will not be 0. Therefore, L square minus 3y square is 0. Implies L square is equal to 3y square. Okay. L square is equal to 3y square. I will substitute L square in this particular expression 1. So I will retain that even. The definition will be taken here because I need that diagram. So therefore L square is equal to 3y square. Now x square is equal to L square minus y square. Therefore x square is equal to L square is what? L square is 3y square. 3y square minus y square, because this is the equation 1, this is 1, let us call it as 1, this is 2, by 1, no by 1, by equation 1, I have taken the equation 1, that equation 1 says that x square is equal to L square minus y square, therefore x square is equal to 3y square, because by equation 2, here L square is equal to 3y square, I got L square is equal to 3y square. That is substitution is taken, L square is 3y square, that is x square is equal to 2y square. That is x square by y square is equal to root 2. Taking square root, by taking square root, x by y. Therefore, taking square root, okay, taking square root by taking square root. By taking square root, what happens? Root of x square upon y square is root x square is x, y square is y, is equal to not root 2, no big deal. What is the x by y? Look here, x by y, x is the opposite, y is the adjacent for the angle theta. Theta is the semi-vertical angle. Here you write down theta is the semi-vertical angle. Theta is the semi-vertical angle, okay. Theta is the semi-vertical angle, here only I will write. Theta is the semi-vertical angle, okay. Here it is right, okay. Theta is the semi-vertical angle. Semi-vertical angle. Semi-vertical angle, okay. Theta is not visible, but I am dictating, no, theta is the semi-vertical angle, include that point. Now, this is nothing but x by y is what? X is opposite, y is adjacent for this theta, and L is the hypotenuse of the triangle. Therefore, opposite upon adjacent is nothing but tan theta. That implies tan theta is root 2. Implies theta is tan root 2. No need to prove second order derivative is negative. For maximum, second order derivative is negative for statement problem. Actually, no need to prove the second order derivative, positive or negative for minimum and maximum respectively. But in the first two problems it is taken, but for this geometrical figure problems, no need to take it. Okay, simply waste of time. Geometrical figure problems is not necessary, because in the problem it is mentioned volume is maximum, area is maximum or minimum is mentioned, means we have no need to prove they are maximum and minimum. If you would like to prove they are maximum and minimum, then you have to prove that second order derivative is negative or positive. But by the given condition, the volume is maximum, surface area is maximum or minimum, like that. We have to prove the given, we have to prove some what it is expressions. Here it is theta is tan inverse root 2, like that. That's why there is no need to what it is take the second order derivative negative or positive. For a geometrical figure it is not necessary. Okay. Next problem. Prove that the following functions do not have maxima and minima. Suppose the what it is function is not having the extreme values. By taking what it is f dash of x to 0, you will get the extreme values. Extreme values means point of maxima or point of minima. Means you are getting x is equals to c. If there is no extreme values, then we can say that the function is neither maximum nor minimum. F dash of x and 0 ke equate ಮಾಡಿದ್ರೆ ನಿಮಗೆ x is equals to c. They are called as extreme values or what it is point of maxima or point of minima or critical points ಅಂತ ಹೇಳ್ತೀವಿ. Extreme values, critical points or point of maxima or point of minima. If you are not at all getting any x values, then we can conclude that the function is neither maximum nor minimum. Okay. Prove that the following functions do not have maxima and minima. Okay, do not have maxima and minima. Means there is no extreme values. How to get the extreme values? By taking first order derivative to 0. F dash of x or dy by dx to 0, we get extreme values. If there is no extreme values, we can conclude that the function has no maxima and no minima. Okay, one or two I will try. Remaining is homework for you. F of x is equals to, first one, f of x is equals to e raised to x. Differentiating with respect to x. D by dx of f of x is equals to d by dx of e raised to x. F dash of x is equals to e raised to x. In maxima and minima problem, that is a common point. Always you have to find f dash of x means dy by dx and take f dash of x to 0. In all problem, it is common feature. Okay, it is a common feature. Take f dash of x to 0 or dy by dx to 0. If the function is taken as 1, then it is you are getting dy by dx. Take dy by dx to 0. So therefore f dash of x is 0. F dash of x, take f dash of x is 0. Implies e raised to x is 0. But e raised to x will never be 0. X belongs to the domain of exponential function. It is an exponential function. It is an exponential function e raised to x, e raised to x. E raised to x, e raised to x will never be 0. Okay? X belongs to R. So x belongs, but e raised to x is always greater than 0. 0 ಆಗೋದನೇ ಇಲ್ಲ, ಯಾವತ್ತೂ positive. Exponential function study ಮಾಡಿದ್ರೆ exponential function will be always positive. The range of exponential function is 0 to infinity. It takes open interval. One takes 0, above 0. Always it takes positive values up to infinity. One takes infinity. Okay, 0 to infinity, open interval, e raised to x. Because e raised to x belongs to 0 to infinity. E raised to x values are in between 0 to infinity. Therefore, e raised to x, but therefore, it implies there is no values of x. There is no values of x belongs to R. Belongs to R. So that f dash of x is 0. F dash of x is 0 ಬರುವಂತ ಯಾವ x ಗಳು ಇಲ್ಲ. Means there is no extreme values. No extreme values means the function will not have any maxima and minima. Okay, implies no extreme values. No extreme values means x is equals to c. By taking f dash of x is equal to 0, you are getting x is equals to c. No, that c is called extreme values. No extreme values. Values for f of x is equals to e raised to x. Therefore, f of x is equals to at the extreme values only the function will be maximum and minimum. ಅವೇ ಇಲ್ಲ ಅಂದಮೇಲೆ ಇಲ್ಲಿ maximum and minimum ಆಗುತ್ತೆ ಹೌದಾ. Therefore there is no maxima and minima. Therefore the function f of x function f of x is equals to e raised to x is neither maximum nor minimum. Neither maximum nor minimum. Second one is f of x g of x is equals to log x. Second one, g of x is equals to log x. Second one, g of x is equals to log x. We know that the domain of the log x is x belongs to in log x function, x will not be negative. Log of negative number is not defined. Log of -3, log of -0.1 is not possible. Logarithm is defined only for positive numbers, log x. Okay, differentiating with respect to x. d by dx of g of x is equals to d by dx of log x. G of x means differentiation is g dash of x. Log x differentiation 1 by x. Take g dash of x, maxima or minima. The common condition is first order derivative is equals to 0. Take g dash of x to 0. G dash of x is equals to 0. Therefore 1 by x is equals to 0. It is not defined. 1 by x is 0. It is not defined. Is it not? So it implies x is equals to infinity. Because 1 by infinity is equals to 0. Okay? Does not belongs to what it is? 0 to infinity. 0 to infinity. Infinity open intervalism. X. What critical value of what? X is infinity. But x is equals to infinity. X is equals to infinity. Does not belongs to 0 to infinity. Infinity does not belongs to any interval. X won't takes infinity only. X go minus infinity plus infinity and ತೊಗೊಳೋದಿಲ್ಲ x and y. Okay. Therefore, no critical point means there is no extreme values. There is no extreme values for the function. Extreme at the extreme values only means x is equals to c. They are called extreme values. How to get x is equals to c? By taking first order derivative dy by dx or f dash of x to 0, you will get x values. Those x values are called extreme values. If no extreme values, at the extreme values only the function will be maximum or minimum. If no extreme values, means there is no maximum or minimum. So there is no extreme values. Extreme values for the function. For the function f of x is equals to log x. Therefore, the function is neither increasing nor decreasing. Therefore, the function is neither increasing nor decreasing. Therefore, the function is neither increasing, neither maxima nor minima. ಹೀಗೆ ಬಂದಿರುತ್ತೆ ಕರ್ವ್. Actually, log x ಕರ್ವ್ ಹೀಗಾಗುತ್ತಲ್ವಾ? Log x curve is like this. ಹೋಗ್ತಾ ಹೋಗುತ್ತೆ. ಹೌದಾ? ಇದು ಕಂಟಿನ್ಯೂ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. At the both the end it continues. Therefore, no definite exact maximum value, no definite exact minimum value because curve continues. ಹಾಗೆ ಒಂದು particular point ಅಲ್ಲಿ maximum minimum ಅಂತ ಹೇಳಲಿಕ್ಕೆ ಸಾಧ್ಯನೇ ಆಗೋದಿಲ್ಲ. So, curve keeps on increasing. Maximum value keeps on increases, and here in the left side curve keeps on decreasing, means minimum value keeps on decreasing. Therefore, no, it is difficult to hold one exact maximum value, exact minimum value. Third one is same. Here h of x is equals to triangle set x cube plus x square plus x plus 1. X is a polynomial function. X belongs to R. What is the domain of this function? Domain is set of x's, possible values of x. What are the values? X. What are the values? Can be taken by x. That is the domain. X is r here. R is minus infinity to plus infinity. You know, h dash of x, differentiating with respect to x, you are getting h dash of x, 3x square plus 2x plus 1. ಅದನ್ನು 0 ಗೆ equate ಮಾಡಿದರೆ quadratic equation ಆಗುತ್ತೆ. So suppose x values not possible to get x values by factorization. You use the formula x is equals to minus b plus or minus root of b square minus 4ac upon 2a. Just use it. Then you are getting square root of negative is imaginary ಆಗುತ್ತೆ. You are getting square root of negative ಬಂದ್ಬಿಡುತ್ತೆ. Square root of negative is imaginary, but x is an imaginary number is not possible because x is a real number. X belongs to R means x is imaginary and square root of negative is r. That's the root of square root of minus 1 is r. I will do the square root of negative. Square root of minus 4 is 2i. Square root of minus 4 minus under I ಆಯಿತು. 4 ಅಂದರೆ 2 ಆಯಿತು. Therefore, if square root of minus you got, then x is equals to imaginary ಆಗೋಯ್ತು, but x is a real number. Therefore, no critical values. X is I ಬರುತ್ತೆ ಬಹುಶಃ ಟ್ರೈ ಮಾಡಿ ಸಿಂಪಲ್. But x ನ ಫ್ಯಾಕ್ಟರೈಸ್ ಮಾಡಲಿಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ, ಈಕ್ವೇಷನ್ ಫ್ಯಾಕ್ಟರೈಸ್ ಮಾಡಲಿಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ. After getting h dash of x, take h dash of x to 0 and factorization of that equation is not possible. Then you take what is the formula to get x values, minus b plus or minus root of b square minus 4ac upon 2a. Then if you are getting square root of negative, means x is equals to I ಆಗುತ್ತೆ. Suppose you got x is equals to minus 3 plus or minus root of minus 4 upon 2. Root of minus 4 means what? Minus 3 plus or minus root 4 is 2, root of minus is r, 2i upon 2. ಇದು root 4 ever ಬರ್ತದೆ, root 5 ಬರ್ತದೆ, root 5r, root of minus 1 is r, root 5r. ಹೀಗಾಗುತ್ತೆ. I outside. Square root of minus 1 is r, separate ಆಯಿತು. root 5. Imaginary. X is imaginary is not possible because x is a real number. Imaginary ಬರೋದಿಲ್ಲ. X is not a real number, not an imaginary number. X will be a real number in this problem. Therefore, no extreme values. Hence, there is no maxima and minima. ಇಷ್ಟೆಲ್ಲ ಇದೆ ನೋಡಿ, ಟ್ರೈ ಮಾಡಿ. Last problem on maxima and minima. Find the absolute maximum and minimum values of the function. F is given by a new word, absolute maximum and absolute minimum. Nothing new in it. Find the maximum and minimum value of the function by taking first order derivative and second order derivative. First order derivative to 0, you are getting x values, and this x values is to be substituted in second order derivative. Then if second order derivative is positive, that x is the point of minima, and if second order derivative is negative, that x value is the point of maximum. Substitute x values in original function of x, will get the maximum and minimum values. So beginning it is taken. So at the same time, absolute, the word absolute, find the absolute maxima and minimum values, maximum and minimum values, absolute maximum and minimum values of the function f given by this is the function f. Okay, find the maximum and minimum values at the critical points, that they are called local maximum and local minimum. At the same time, in main boundary is there actually. A closed interval is there that I have not written in the interval. For absolute maxima and absolute minima, a closed interval is very must. In 1 to 5. In closed interval 1 to 5. So here is a closed interval for absolute maxima and minima. The x belongs to one closed interval will be given. These are 1 and 5 for boundary values. Work out the values of f of x and the boundary values also. F of 1 you work out, f of 5 you work out. Now you are having the local maxima and local minima obtained by first derivative, second derivative, obtained by first order derivative and second order derivative. You are having the values of the function at the boundary values 1 and 5. This is a, this is b. So you are having the values f of a and f of b. Among all these, which one is maximum one? That's the absolute maximum. Among the local maximum and local minimum, which is obtained by taking first order derivative to 0 and second order derivative, x values you are getting, second order derivative is positive, then it is a minimum point, and second order derivative is positive, that is the point of maxima. So find the local maxima and local minima by using first order derivative and second order derivative. Second order derivative test it is called. And also find the values of the function at the boundary values. So among the four values, which one is maximum, that is the absolute maximum, and which one is the minimum, that is the absolute minimum. Okay, here is the note is given. Absolute maximum or minimum values of a function is the maximum or minimum value of the function at the extreme points x is equals to c. Which one is maximum among the maximum minimum at the extreme points x is equals to c. How to get the extreme points? By taking f dash of x is 0. Or at the boundary values x is equals to a and x is equals to b of the interval I is equals to a to b. At this interval will be given for x. So here is a is 1, b is 5, f of 1 and f of 5 are the values of the function at the boundary values. And you have to get the local minima, local maxima by second order derivative test. Among all, which one is maximum, that is the absolute maximum. Among all, which one is minimum, that is the absolute minimum. So coming to the problem, you will get the idea by solving the problem. Let us start solve it. F of x is equals to third one. In 3 minutes is remaining. F of x is equals to 2x cube minus 15x square plus 36x plus 1. F dash of x is equals to 6x square. X cube differentiation is 3x square. 3 into 2. 15 into differentiation of x square 2x. 15 into 2, 30x. Plus 36 into differentiation of x is 1. 36. Plus 1 differentiation is 0. F double dash of x. Again differentiating it. 6x square differentiation. 12x minus 30. 30 into 1 is 30. Okay. 36 differentiation is 0. Differentiating with respect to x, I got f dash of x, again differentiating with respect to x, therefore, and this f dash of x is differentiated, you got f double dash of x. Take f dash of x to 0. F dash of x is 0 implies 6x square minus 30x plus 36 is 0. 6 is common. X square minus 5x plus 6 is 0 implies x square minus 5x plus 6 is 0. 6 ones are 6. What are the minus 5 are like minus 3 into minus 2. X minus 3 into x minus 2 equals to 0 implies x is equals to 3 or x is equals to 2. And what the critical values, extreme values. At what point maxima or minima? To the second order derivative test. F double dash of x at x is equals to 3 is equals to 12 into 3 minus 30 is equals to 6 greater than 0 implies f of x is minimum. Second order derivative is positive means is minimum. Minimum at x is equals to 3. Now therefore minimum value of f of x, minimum value of f of x is equals to, in f of x, to take minimum value of f of x is equals to, in f of x, to take x is equals to 3. F of x is 2x cube, 3 cube is 27, 2 into 27 minus 15 into 9 plus 36 into 3 plus 1. 27 to the 54 minus 59 to the 35 plus 36 is 108 plus 1. 108 plus 1, 109. 109 plus 54, 163. 163 minus 135. That's equals to 28. So this is the minimum value, local minimum I got. Okay. Now another critical point is x is 2. No. F double dash of x. What about x is equals to 3, the point of minimum? X is equals to 2 in f double dash of x. Take x is equals to 2. X is equals to 2. That's equals to f double dash of x is, it is f double dash of x. 12 into 2 minus 30, that's equals to minus 6 negative. Therefore x is equals to 2 is the point of minimum. Maxima.